Hello students, in this video we'll understand some basic concepts related to chapter 16 from grade 10th ICSE Locus. So what we'll understand is the four important loci that we have in this chapter. So let us begin with the first one. The first one is locus of points which are equidistant, that means they are at equal distance from a given point in the same plane. So let's say students that in a given plane, if we have a point O, now we are talking about points which will be at equal distance from this point O. So let's say from this point O we have a point which is at a distance of 3 centimeters. So this is the first point P at distance 3 centimeter. What you have to understand is students, there can be many such points which are at distance of 3 from point O. Another point can be somewhere over here, distance of 3 centimeter. There is another possibility of a point at 3 centimeter. And you have to understand students, there are infinite such points which are possible throughout the plane. And when you join all these points, the collection, that is the locus, is nothing but a circle. This circle has center at that fixed point O, and the radius is that fixed distance, which was 3 in this example. So the locus is simply a circle. So remember students, if one point is given, then the locus is simply going to be a circle. So when one point is given in the question and some distance will be given, 3 centimeter or 4 centimeter, it's going to be a circle with that point as center and the radius will be that fixed distance. Further, let's move ahead to the second locus. The second locus will be locus of a point which is equidistant from end points of a given segment. And when we say end points of given segment, we are talking about 2 points. In the previous example, it was 1 point. Here, there are 2 points. So here, students, let's say we have a segment AB. The length will be given in the question. And we are talking about points which are at equal distance from A and B. So let's consider a point P which is at equal distance, that is PA and PD will be equal. Now you have to understand we can have many more such points. Another point Q is possible such that QA will be equal to QB. Now what you have to understand, students, that this distance PA will be equal to PB. If PA is 3, PB is 3. If QA is 4, QB is also 4. But what you have to understand is obviously PA and QA distances will not be same. We are talking about the distance in comparison with these 2 points A and B. So PA and PB is same. And students, we can have infinite such points. And the collection of all those infinite points is simply going to be a special line. If you look at the figure carefully, this line will be a perpendicular bisector. So it's going to be perpendicular and it will exactly cut AB at the midpoint. So it's going to be a perpendicular bisector of AB. So in the question when they say draw a locus of points equidistant from A and B, it means they are talking about perpendicular bisector of AB. So if it's 2 points, it's perpendicular bisector. Now let's understand how to draw a perpendicular bisector. So let's say students, if we have a segment AB, the length will already be given to us. So we have the length of AB and we have to draw a perpendicular bisector. So at the end points A and B, you have to now keep the compass. The radius has to be more than half, remember. So more than half of AB, you have to take that by judgment. You have to cut an arc above AB and below AB from point A, and then you have to cut an arc from B, again above AB and below AB, and it should cut the previous arcs. And these point of intersection, students, just join them. This is our perpendicular bisector. So this is the perpendicular bisector of AB. Let's proceed to the third locus. The third locus is locus of points equidistant from the sides of a given angle, from the arms of a given angle. So let's consider an angle. The angle measurement will be given. I expect you to know how to construct angles. So once you draw the angle, let's consider a point P such that the distance of P from BC and the distance of P from AB, that is PM and PN, is equal. This distance should be equal. Now once you understand that this distance is equal, there can be infinite such points such that the distance is equal. So we can have another point Q such that the distance is equal, and we'll have infinite such points. Now the collection of all these points, students, is a special line. That line, if you look at this figure, it's very understandable that it's going to be the angle bisector of this angle B. So now students, let's understand how to construct an angle bisector. The locus is going to be an angle bisector. Let's understand how to draw an angle bisector. I expect you to already know how to draw angles. So let's consider an angle over here. Now let's understand how will we draw the bisector. So for the bisector students, we want the angle bisector of B. We'll keep the compass at B. The radius by judgment has to be less than half, and we'll cut an arc on both the sides, that is on AB and also on BC. And you can also cut a continuous arc as well. It doesn't make a difference. Now you have to keep the compass at these points, and you have to cut another arc somewhere in between the angle, and this will be another arc from Y, and just join this point D with this new intersection. This, students, is the angle bisector. Further, let's proceed to the fourth locus. The fourth locus is locus of points which are equidistant from a given line. So this time a line will be given to us. Length will be given to us. We are talking about points which are at equal distance from this line. Let's consider a point which is at a distance of 2 cm from this line. Do you understand, students? There will be infinite such points possible. We can have another point Q which is at 2 cm distance. We can have another point R which is at 2 cm distance, and we have infinite such points. When we join all these points, you look at the figure, it's understandable that this is going to be a line which is parallel to the previous line, to the given line. And you also realize that when we talk about distance being 2 cm, there is another parallel line possible which will be under the given line. So this will be the locus. It will be a collection of two parallel lines. It will be a pair of parallel lines. So in this case, when one line is given, the locus is going to be pair of parallel lines, and the distance will be mentioned in the question. So now students, let's summarize this quickly. There are 4 things which you have to remember. If one point is given in the question, we'll draw a circle because the locus will be a circle. If 2 points A and B are given, it's going to be a perpendicular bisector of AB. If 2 lines are given, like AB and BC, we are talking about an angle over here, remember? It's going to be an angle bisector. The only thing which you have to decide, angle bisector of which angle. For that, the trick is very simple. Always refer to the common angle. If you want the locus of points equidistant from AB and BC, the common letter is angle B. So it's angle bisector of angle B. And the last one, if we have one line, the locus will be pair of parallel lines. So now students, take out your textbooks. Practice questions based on locus. It's a very simple chapter. Thank you.